Hello everyone, this is Devashish again from Dev's Learning Hub. So today we are going to cover a very interesting topic, graphical representation. How to represent graphically any continuous or group data where the class interval is there, right? How to do that? So for median, to find out median, lower quartile, upper quartile and thereafter interquartile range, for that we normally use OGIVE, particularly the less than OGIVE. And to calculate mode for group data or continuous data, we utilize histogram. So histogram and mode, how to find out mode for group data using histogram, that I will cover up in a separate video. Here we will understand first what is the concept of OGIVE. If you understand the concept, it's very easy for you to find out median, lower quartile and upper quartile using OGIVE. So, and what are the different types of OGIVE curve? It is there less than OGIVE, another is more than OGIVE. Less than OGIVE, here also we utilize another very popular term, less than OGIVE, it is or less than cumulative frequency curve. And for more than OGIVE, it is termed as more than cumulative frequency curve. So if somewhere it says using less than cumulative function curve, you identify the median, that means it's same like less than OGIVE. Right? And why it is less than or more than and why it is cumulative frequency, that you will understand when I will explain both of these two. Right? And next we will see utility of OGIVE. What is the utility of less than and more than OGIVE with practical example? Okay. So let's start it. Today we will explain the OGIVE utilizing this group data. What you can see here, right? There we have the class interval in the first column, and in the second column we have the respective frequency against each of the class interval or the group data. Then we will calculate, we will fill up the rest of the columns, and then we will draw the graph. We will draw the less than OGIVE curve and more than OGIVE curve, and then you will understand exactly what it is and why it is used. Okay? So for less than OGIVE, you can see in this particular table, after frequency you have two columns, CF, C dot F dot C, that means cumulative frequency. The full form is cumulative frequency. That's the term already you know, cumulative frequency. And the next column is graphical points XY. That means when we will plot the data graphically, then which will be the along the x-axis, which will be along the y-axis. And this cumulative frequency and the graphical points against, you look into the top representation, that is for less than OGIVE. And we will calculate the same cumulative frequency and graphical points also for more than OGIVE. And we will draw both the less than OGIVE and more than OGIVE in the same graph. So you can differentiate both the curves actually. Right? So for finding out the cumulative frequency for less than OGIVE, how we will calculate the cumulative frequency? Cumulative frequency, normally what we do 5, then the next one is 5 plus 7, 12, then 12 plus 10, 22. How we do that? We do like this. So the cumulative frequency, we will take the cumulative frequency for all of the classes. Then I will show, explain you exactly what does it mean. So 5, the first one cumulative frequency, it is 5. So first one is 5, second one is 5 plus 7, it is 12. Then it is 12 plus 10. So we will add up each of the frequency with its next frequency. And then the resulting frequency, cumulative frequency, we will add up for the next frequency. So 5, first one is 5, this is the first one. 5 plus 7, 12, 12 plus 10, 22. 22 plus 8, that is 30. 30 plus 5, that is 35. So actually, if you sum up the entire frequency, that will come up 35. 5 plus 7, 12, 12 plus 10, 22, 22 plus 8, 30, 30 plus 5, 35. So actually summation of F, that is 35. So now, for less than OGIVE, when we'll plot these graphical points, we will write down the graphical points. What we will do, along the x-axis, we will put the upper bound of each of the class interval. So let me draw the graph first, the axis first. Okay, so if you look into this graph, so along the x-axis it is CI, that's the class interval, and along the y-axis you have the cumulative frequency. But in class interval you have each of the interval, you have lower bound and upper bound. 0 to 10, 0 is the lower bound, 10 is the upper bound. 20 to 30, 20 is the lower bound, 30 is the upper bound. So which value will take upper bound or lower bound across class x-axis? That will say along the x-axis. And along the y-axis, the cumulative frequency for less than ogive already we have calculated 5, 12, 22, 30, 35. Actually, what does it mean? Now understand. So that you will fill it up very quickly for the graphical points and why it is called less than ogive. So firstly, let me just mechanically put the point and then I will explain it. So for the graphical points, along the x-axis you will have the class interval, and for less than ogive, we will take upper bound for each of the class interval on the x-axis. So what will be the point? For x, it will be 10. For 0 to 10, we will take 10. And for cumulative frequency, that we have calculated 5. For next one, 10 to 20, because for less than ogive, we will take only the upper bound for against each of the class interval and we will take the respective cumulative frequency. So here it will be 20 and the cumulative frequency it is 12. Here it will be 30 and 22. 30 and then 22. 30 to 40. Here it will be 40 and what is the cumulative frequency? 30. 40, 30. Here it will be 50 upper bound and cumulative frequency 35. So 50 and then it is 35. Now, all the points we will plot graphically here. So what exactly interpretation? What is the interpretation? If we take the upper bound, that means below 10, 0 to 10 means it gives the frequency up to 10. Let's say in this class interval, so value 10, so 10 and below, it is 5 data points are there. 10 and below. So 10 and below, 10 equal to 10 and less than 10, it has 5 data points. Below 20, 10 to 20, you have the frequency 7. But if I say not 10 to 20, 20 and below. 20 and below means it is 7 plus 5, 12. Because it is also considering 0 to the data points that belongs to 0 to 10. So it considers both the frequency of 10 to 20 as well as the frequency of 0 to 10. That is what actually it considers. That means 0 to 20. 20 and below means it considers from 0 to 20. How many data points? 5 plus 7, 12. That is why for less than frequency, we are adding up the frequency subsequently, right? On a consecutive row. So next, if I say 20 and below, it is 12. Next, if we say 30 and below, how many data points are there? That means 30 and below means from 0 to 30. So 30 and below, how many data points here? 20 to 30, it is 10. 10 to 20, it is 7. 0 to 10, it is 5. That means 30 and below, it is total cumulative points. It is 10 plus 7 plus 5, 22. So cumulative frequency, how you calculate that you know, but actually what is the data interpretation that I am trying to make you understand. So now next cumulative frequency is 22 plus 8, that is 30. So diagonally, zigzag way it is just adding up. So 22 plus 8, 30. So what is the interpretation of this particular class interval and cumulative frequency? If I take 40 as upper bound, that means 40 and below, how many it is there? 30. So how this 30 is coming? 8 plus 10, because it considers this 8 as well as the previous class intervals too. So 8 plus 10, 18, 18 plus 7, 25, 25 plus 5, 30. So that is what you are getting 30. And 50 and below, that means total all the 35 points. So cumulative frequency, you are adding up all the frequency one by one. And what is the meaning of this less than, why we are taking the upper bound and why we will plot the data. So everywhere along the x-axis we are plotting the class interval. So class interval upper bound we are taking for less than ogive. So we will take 10 and the respective cumulative frequency for that upper class interval. So 10, 10, 5, 20, 12, 20, 12, 30, 22, 30, 22, 40, 30, 40, 30, 50, 35, 50, 35. So now we will plot these points. But before plotting these points, let me do the same thing also for more than ogive. Then we will plot the data for both the curves, right? Now for more than ogive, what we will do, we'll do the we are going to take? We are going to take the lower bound against each of the class interval. Here we are taking upper bound and then we are saying below that point, 10 or less than 10, 20 or less than 20. Since we will take the lower bound here, there we will consider 0 and above. How many points are there? So we can see the total, the cumulative frequency is 35. That means total across class intervals you have total 35 data points. So 0 is the minimum observation value. So 0 to 10 you have 5 data points. But if I say above 0, that means it will consider 0 to 50 altogether. That means all the data points. To 0, now here we will consider the lower bound, right? So for more than ogive, we will consider lower bound of the class interval. Lower bound. And for cumulative frequency less than ogive, here we will consider upper bound. It's a bit smaller, but since I am saying you understand very easily. So for less than ogive, we will consider the upper bound for each of the class interval. And for more than ogive, we will consider the lower bound. Now, if we consider lower bound, that means 0 is lower. So 0 and above, how many points are there? Total 35 points. So 35 is the cumulative frequency here. 10, here the lower bound is 10. So 10 and above. Below 10 you can see 10 and above. Right? So 10 and above means 35 data points you have total. 10 to 20 you have 7, but below 10 you have 5. So 10 and above means you will calculate the cumulative frequency by excluding the previous one. That means 35 minus 5. So it will be 35 minus 5, that is equals to 30. Now next one. For this class interval, for more than ogive, we are considering the lower bound. So 20 and above. How many data points are there? 10 plus 8 plus 5. 23. So actually we are excluding 35 minus the previous one, 12. So both ways you can calculate. Either you can start from here and you can sum up rest of the frequencies also along with that, or you can deduct the previous class intervals, sum up the frequency of the previous class intervals, and then you deduct it from the total cumulative frequency. So both ways you can do. Either you can do 20 and above. How many data points you have? 10 plus 8 plus 5, 20 to 30, 10, 30 to 40, that is also above 28, 40 to 50, that is also above 20. That means 10 plus 8 plus 5, 23. So either you can say 10 plus 8 plus 5, 23, or you can say 35 minus 12, because 10 to 20 and 0 to 10, that is below 20. So 5 plus 7, 12. So either 30, how you can do the calculation? Either you can do 35 minus 5 plus 7 equals to 23, or you can say, just I am calculating for one row, 10 plus 8 plus 5, that is equals to 23. So both ways you can do that. The same thing for 10 and above. 10 and above, either 7 plus 10, 17 plus 8, 25, 25 plus 5, 30. Or here you can do the cumulative frequency 35 minus, you will exclude below 10, that is 5. So 35 minus 5, 30. So that's the concept, that's the understanding you should have why we are considering upper bound for less than ogive and why we are considering lower bound for more than ogive. And why the cumulative frequency, these two have two different values. This is the most important concept for less than ogive and more than ogive. Rest are very simple. Right? So hope you understand why it is called less than ogive, why it is called more than ogive. For less than ogive, we are considering the upper bound and then you are doing the cumulative frequency, and therefore your interpretation is upper bound data equal to the upper bound data or less than that. And for more than ogive, equal to the lower than data, lower bound data, value or more than that. Right? So now what will be the data points? Same thing, we will consider across class interval, we will have across x-axis we have class interval. So here our class interval value will be the lower bound data. Here we will have, here we had lower bound data, upper bound data, here we will have lower bound data. So lower bound data means 0, and what is the cumulative frequency? That is 35. 0, 35. Here it is 10 and then 30. 10, 30. 20 to 30. Lower bound is 20, cumulative frequency 23. So 20, 23. Next is 30 lower bound and 30 lower bound. And what is the cumulative frequency? That we need to calculate. Here it is 30 and above. That means 13. It is either you can say 30, either you can say 35 minus 5 plus 7 plus 10, that is 22. 35 minus 22, that is equals to 13. Or you can say 8 plus 5 equals to 13. So actually the point will be lower bound 30 and then 13. So 30 and 13. 40 and above, you have only 5 points. So that will be 40 and 5. So cumulative frequency will be 5. So 40 and 5. So now we will just concentrate on these two columns, that is graphical points for less than ogive and graphical points for more than ogive. That is how we will plot it across the curve, and let's see how the curve looks like for less than ogive and more than ogive. So now let me plot the less than ogive graphical points first, that is 10, 5. If you look into this graphical representation, actually you will be given actual graph paper. But here, just for your understanding, I will let you know the process, exactly what to do. So might be there will be minor differences if you plot the data graphically. So that you will do eye estimation. So what is the scale I have taken here? Each of the small one, you can see each of all are 5 units, right? 5, 10, 15, 20, 25, 30 and up to 45. Sorry, up to 50. It should be 50. So it is 40, it is 45 and then it is 50. Last one is 50. Now let's plot the data for less than ogive. Less than ogive we see 10, 5. Along the x-axis 10, along y-axis 5. So 10. And then similarly, along the y-axis there is a cumulative frequency, also it is 5, 10, 15, 20, 25, 30, 35. So 10, 5. That means this is 5. This is 10, this is 5. Along the y-axis, this is 5. So actually this point is 10, 5. Next is 20, 12. So it is 20 and 10 it is here, assuming 12 will be like this. So you need to do the parallel of x-axis, right? 20, 12 and perpendicular from here. 20, 12 means, so near like this one, right? And then it is 50, 35. 50, 35. Right? So, how the curve will look like? Since your class interval started from 0, so basically how the curve will look like? Curve will look like this. Right? So this is what your less than ogive curve. Now, if I say why this curve is so useful, that we will explain. And now we will plot the data for more than ogive. So for less than ogive, what we can see, the value of cumulative frequency is gradually increasing towards the positive direction. So the slope is actually gradually increasing. Right? Now we will plot the data for more than ogive. More than ogive, it is 0, 35. So x-axis 0 and then it is 35. This is 1 point. Then it is 10, 30. 10 and then it is 30. Sorry, this point. Right? Next it is 45. 40 and then 5. So 5 will be this one. So 45. So now how we will plot the data? I will adjoin all the points. Why I am doing it up to 50? Because the data is from 0 to 50. 0 is the lowest one, observation value, 50 is the highest observation value, right? And for this one also 50 to 0. So now this one is the black one, it is more than ogive. So now you can distinguish fairly from this curve, from this graphical representation, that less than ogive, gradually the cumulative frequency is increasing, and for less than more than ogive, gradually the cumulative frequency is decreasing from left to right. So now what does it mean at any given point? For less than ogive, if I see this point, that is x-axis, along the x-axis 20, and along the y-axis it is 12. So 20, 12. Let's say forget about this table. Just this curve is given. Now you can see this one is the less than ogive, this one is the more than ogive. So just by looking into the graph, how can you, what you can represent from the data? You can represent the data from the data itself. You can see that if it is say 2012, this point is 2012. What does it mean? On the less than ogive, it means that you have 20, it is 12, okay, right. So you have total 12 data points at 20 or less than 20. So 12 candidates are there, 12 observation values are there, 20 and including 20 and less than 20, not more than. Because less than ogive curve, that's how it is interpreted, and why it is so already I have told you while calculating the cumulative frequency. This point, what is this point? It is 30, right? It is sorry, from 40 you are going. So it is 30 is the cumulative frequency and 40 is the observation value, right? So you have total 30 data points for observation values equal to 40 or less than 40. Less than equals to 40. Rather you can say less than equals to 40. You have same thing for more than ogive. What this data point along the black curve, that is the more than ogive. For more than ogive, what this data point? This data point is 30, and what is the along the x-axis? What is the value? It is 10. That means this value is 1030. 10, 30. So for more than ogive, there are total 30 observation value which has observation values 10 or above 10, 10 or more than 10. Because for more than ogive, you have considered the lower bound. So 10, 20. So above 10, how many values are there? It is 30. So above 10, you have 30. So if you don't have this tabular data with you, only this graph is given and the point you know exactly what is the coordinate of each of the point. In that case, you can easily interpret what does it mean. So that is what the meaning of cumulative function, because other than doing the cumulative, other than finding out the cumulative function, cumulative frequency, you cannot put the data on the less than ogive or more than ogive to formulate less than ogive or more than ogive. So cumulative frequency, or therefore either less than ogive, it is termed also as less than cumulative frequency curve, and the more than ogive, that is also termed as more than cumulative frequency curve, because cumulative frequency, that is the most important part in this less than ogive or more than ogive. How you are calculating, there are two important things. One is selecting lower bound or upper bound, which value of class interval you will select along the x-axis. For less than ogive, you will select the upper bound of the class interval, and for more than ogive, you will select the lower bound of the class interval. That is point number 1. And what is point number 2? Point number 2 is how we will calculate the cumulative frequency. So there you will understand easily while calculating the cumulative frequency why we are considering upper bound and where we are considering the lower bound. Upper bound we are considering to understand how many values are there, how many data points are there below that level, equal to or below that below that value, below a specific value, right? And for more than ogive, we are considering the lower bound data. So therefore, it's interpreting that how many data points are there above that specific value. Okay, so now let's say, not necessarily you will get all the values like 0, 10, 10, 11. I would like to also explain you what does this intersection point actually interprets. The intersecting point of less than ogive and more than ogive. This is actually the median. This point is actually the median. Why it is median? Let's understand that. So this point, let's say this is P. This point is actually the median. Median means the respective x-axis value. That is the median. This one. So this is the median and this is the data point. Which position the median is having? This is the position, and what is the value of the median? This is the median. This is not the value of the median. This is the position of the median, and this is the value of the median. Now, why this median? This is nearby the median value, if it is not exactly equal to, but nearby the median value. Why it is so? Because this particular point P, it's lying on the less than ogive curve as well as it's lying on the more than ogive curve. Now, with respect to less than ogive curve, how this P point is represented? So, let's say P, the name of the point is P, and the coordinate of this P point is xy. So, with respect to less than ogive, LTO, less than ogive, just simplified it, less than ogive, short form, this just my personal perception. There is nothing called LTO. Okay, just for your understanding, I am telling less than ogive, point P. Let's assume the coordinate of point P, xy. So, what this point P represent? P is point, y is the cumulative frequency, x is the observation value. So, what actually this point P indicates? Indicates for with respect to less than ogive, y data points for observation values less than equals to x. That means there are y data points, those are at or those are equal, those have the value equal to x or less than x, right? Now, what this point P, the same coordinate, interprets with respect to more than ogive curve. Now, with respect to more than ogive curve, that is with respect to this black one, right? More than ogive curve, this xy P point represents y data points for observation values. Those are equal to x or greater than x, more than x. Right? The same point P represent y data points for observation values less than or equals to x, and y data points for observation values greater than or equals to x. That means when we are saying y data points with respect to less than ogive, y data points for observation values less than or equals to x, that means it's considering less than or equals to x. That means it's considering the left side of that point. So this point actually represent with respect to less than ogive curve that less than equals to y data points for observation values less than equals to x. So left side of x point you have y data points, and right side of x point it says y data points for with respect to more than ogive, y data points for observation values greater than equals to x. That means greater than equals to x also you have y data points. That means right side of x, right side of this point, at position P, right side of position P and left side of position P has the same data points y. That means if you have the same data points both side of a point, that means that is the median, because you have the 50% median is at the 50% data point. That means median, right side and left side of median you have 50% of observation values, 50% of data. That means this point P actually the median, position of the median point. So respective observation value of this intersection point of less than ogive and more than ogive, the respective observation value, you need to draw the perpendicular on x-axis. That value along the x-axis actually is the median. That means intersection point of less than ogive and more than ogive, it helps to find out the median. Got it? Now, with respect to utility part, now you understand why we say less than or more than in the ogive. Less than ogive, more than ogive, less and more. These two are very important terms. Or why we say less than cumulative function, cumulative frequency curve or more than cumulative frequency curve. This interpretation of the cumulative frequency, that is for both less than and more than ogive. Right? That you understand. Now the utility. The major utility with respect to less than ogive, you can identify median Q1. That is the lower quartile, Q3 upper quartile, and IQR. So if you find out, you can find out Q1 and Q3, the lower quartile and upper quartile. You can easily find out the interquartile range IQR also. So all these things, median, lower quartile, Q1, upper quartile, Q3, and interquartile range, all these things you can easily find out from less than ogive curve. How you will do that? That already I have made one video. For what the link is given in the description section below for this particular video. You can easily find out using less than ogive curve how you can find out median, lower quartile, upper quartile, and thereafter IQR for group data or continuous data. That already I have the video and the link is given in the description section below. Now for more than ogive, the major utility is merge with less than ogive, LTO, and find median, as I have explained. For using along with less than ogive, you can easily find out the median also. Now I will give you one, just utilizing this particular data. I am just trying to figure out exactly what is the importance of less than ogive or more than ogive. Let's say these are the marks given for a maths test where the full marks is 50 and the total number of students appear for that exam, that is 35. Now I have given the range against each of the score class, right? Up to from 0 to 10 scored by 5 students, 10 to 20 scored by 7 students, 20 by 30 scored by 10 students, 30 to 40 scored by 8 candidates, and 40 to 50 scored by 5 candidates. Now somebody wants to understand what is the, how many people they scored less than, let's say to understand the outperformer, how many, 40 to 55, but I would like to understand how many candidates they scored above 45. Above 45, that means more than 45. There you need to utilize more than OGIVE curve, not the less than OGIVE curve. What is the, how many candidates they scored above 45? That means you need to score, you need to mark 45 here. Let's say this is 45, and where this 45, this data point 45, in the graph it could be the value also 42, 41, 43, whatever value it will be ours. From that point you will draw the perpendicular which will intersect the more than OGIVE curve. That is the value, that is, from there you will see the respective value in the y-axis, along the y-axis, that is the cumulative frequency. That means that is the number, that y-axis value. So from this 45 here, it is this y-axis value. This point, the y-axis value at this point will give you the picture how many students they scored 45 and above. So those are outperforming students. Now somebody is asking to find out what is the below performance, right? Where it is required to understand how many people they scored below 5 or below 8. So where you will do, you will mark 8 along the x-axis, right? And then from that value, where actually below 8, that means you need to intersect with the less than OGIVE curve. There you need to draw the perpendicular, and where it will intersect the less than OGIVE curve, let's say 5 and below, how many students scored? This is the point, this y-axis value where it is intersecting the less than OGIVE curve. That means this value is saying that this many number of students scored 5 or below, and this many number of students, the point is on the more than OGIVE curve, scored 45 and above. Same thing you can utilize in the industry also, right? So what is the sales revenue? Which sales representative achieved the target between this and this value? So I would like to understand the top, how many achieved above the target value. Let's say target is given that you need to achieve this amount of sales in this particular quarter. So how many people they achieved beyond the target? How many people they achieved on the target, or how many people they achieved below the target or much less than the target? So all this kind of less than, more than, this kind of thing you can find out straight away from the curve, and the exact value will get when you will plot the data in the graph paper. So the concept, this is what the concept, I hope you understood, right? So this is how you can find out median, lower quartile, upper quartile, top 25%, less above below 25% and below 75% and above, how many scored, right? So there are a lot of practical examples that you can utilize for continuous or group data using this less than OGIVE and more than OGIVE curve, right? So that is what the utility. So I hope your concept is now very much clear. So if you like this video, definitely click on the like button, and if you want to make your fundamental clear, right? So, and would like to see this kind of video again and again, please subscribe my channel. Thank you very much.